Hey, we're back. All right, ladies, I hope that the last lesson went well for you and that you feel like you have a good understanding of patterns and the zero number and how to put it together. Today, we're going to keep going from that point, okay? So if you are not feeling good about patterns or the zero number or putting it together, you should definitely go back and review that information and maybe take another look at the worksheet or send me a message, okay? But let's move on from there. Okay, so I'm on, let's see what here, page 10 of our notes, okay, so you can join me there, and we're going to talk about what does the equation mean, the one that we developed in the last lesson. So, first things first, it's really important to remember that each equation that we that we find, it represents a line, not just the table of values, okay, so that's a super important piece of information that we can't forget. Pardon me. While we are looking at this unit, okay? So that means that when we find an equation, it's not just representing what's in this table of values, but also the line that would extend in either direction. So let's do an example together to show you what I mean, and that should become clear. Okay, so we're going to find the equation from the table of values here shown, okay? And so we can see that we have a +3 pattern going on with the y's when x is +1, which is perfect. And I can also see that we already have the zero number shown. So I can easily put that together to give me y is equal to pattern x plus the zero number. So in this case, y equals 3x plus 1. Okay, so we're going to take some time now to plot the rest of the points, all of the points that are on that table of values that are given here. Okay, so I'm just going to zoom in a little bit to try and make this more accurate. So I have the point 0, 1. There we go. Okay, and then I have 1, 4. Okay, and then I have 2, 7, and you're going to notice that 3, 10 doesn't fit, which is totally okay. So now what we're going to do is we're going to be drawing a straight line through these points. Okay, so I'm going to take my ruler and I'm going to draw a straight line through them. Let me just get this set up here. Okay, there we go. Oh dear, let me try that again. Hang on 2 seconds. I need to just get a better ruler. Okay, this should work better. Okay. Oh goodness, you guys, I'm so sorry. Stylus, it's crazy time. Wow, nope. Okay, we're gonna try one last time. Sorry about all this chaos, you guys. Wow, not intended at all. All right, there we go. That is much better. Okay, and so you're gonna see that I'm not just putting it through the points that are on the graph, though, right? You can see that I'm extending it past the points that are on the table of values, and you can see that I wrote that here, right? Extend it to show the line. Okay, so I'm just going to remind you that when we do this, we are finding the equation of an entire line, right? Not just the points that are on the table of values. So it could be that these points shown here on the table of values are the ones shown, like here. But I could have also shown other points that would have been on this line as well, right? So if you take a look, you can see that this is a point on the line. I know that's messy, I'm sorry, still my stylus. Or that's another point on the line. So those 2 points could have also been included here in that information, but they weren't, and that's okay, but that's why we're extending the line to show that they do exist. Okay. Sorry about that messiness. It is supposed to go like directly through that point in my line, but it doesn't because my stylus is so bad. If you are not sure what I mean, just message me, please, okay? Then we'll get it figured out. All right, so now we are going to talk about the 2 pieces of information, the zero number and the pattern, in more specific and accurate terms, okay? So now that we know that the equation that we make represents a line, okay, then we are going to talk about like what does each piece of information mean in the line. All right, so the first element, of the equation that we're going to look at is called slope, okay? And the slope is represented by the pattern portion of the work we've just been doing, okay? And essentially, the slope tells us how steep a line is. Okay, so whether it's steep or shallow, and how steep or shallow. That's what the slope is going to tell us. And in the above example, we saw that the pattern was +3, right? So if you go back and look, you can see that that's exactly what we wrote here, +3. And so because of that, then the slope of our line is also equal to 3. Okay, if the pattern was -3, then the slope would be -3. Okay, so exactly whatever the pattern is, that's what the slope is equal to. And sometimes, and increasingly so, we're going to see lines without having the table of values with it. And so in that case, we can find the slope just by looking at the line. And the way we can do that is because slope has its own equation. Okay, so that equation is slope, which here you can see it has an m next to it. That's because slope in math is represented by the letter m, the variable m. And slope is equal to rise divided by run. Okay, and this is a super great thing to talk about slope because it's really like a visual device, right? So it explains on its own without me having to use many other words already what the slope of the line represents, which is the rise, which we could talk about as the vertical change, over the run, which we can talk about as the horizontal change. Okay, and just a quick note that this is like a fraction line, okay, like I'm talking about division here. Okay, so rise over run or vertical change over horizontal change. And it's important to note that slope can be expressed as a fraction, as a whole number, let's try that again, there we go, whole number, or as a decimal. Okay, so all three of those are appropriate values for slope. So we're going to see all three of those through this unit. Slope also can be a negative. I don't have space. I'm just going to shorten there to neg, okay, or positive. Let's see if I have space for this one. There we go, or positive number. And some examples of slope can be essentially any number. That's a fraction, whole number, or decimal. Okay, so some examples are 4/3, or maybe 0.2, maybe -5, or 0, or -1/2. Okay, so any of those are just examples, right? So any other number that you can think of that is a fraction, whole number, or decimal, and that's negative, positive, or 0, those are all options for slope. Okay, so we can see slope as pretty much any line, or any number, pardon me, in that line. Okay. Now, to determine the slope of each line that's shown below, as the example is asking us to do, what we're essentially going to have to do is use that rise over run that I was just talking about. Okay, so rise over run again is the vertical change over the horizontal change. So the way that this is going to happen is we're just going to pick 2 points on the line. Okay, so let's start with the blue line because I'm writing in blue. Okay, so we can see that we have this blue line here, right? So it has a bunch of points on it, and we are going to just pick 2 points. Now, I'm going to pick this point right here. Okay, and actually the origin, the starting point. The reason I'm picking those points is because you can see that along the line here and along the line here, there are points, but none of them are exact, right? None of them actually meet at like a point. They're all kind of in the middle, like here, right? Like it's in between squares, or in between lines in the middle of the square, and so it's harder to calculate using that. So I'd always recommend that you find solid points to work with. Okay, and then once you have that, what we're going to do is just calculate that rise and the run. Okay, so we know that slope is equal to rise over run. And in this case, we're just going to do some counting to figure those out. Okay, so let me just switch to a brighter color here so you can see it. So you can count the rise or the run first. It doesn't really matter, but I always start at the left point and move to the right point. Okay, that's important. So if you need to write that down, pause the video and do so. I'm always going to start at the left point of the 2 that I chose. So in this case, this point, and then move to the right point, which is the one I circled second. okay? So the left point is here, and I'm going to count the rise. So I'm going to go from the level of the first point, the left point. I'm going to go to the level of the second point, or the right point, okay? And so I can see that if I go up here, I'm going up 2 squares, right? I went from here all the way to here. And that is the first step. But then we're going to look at this axis here, right? We're going to see that each square represents 25 units, right? And so by going up 2 squares here, I'm going up 50, right? So I went from 0 to 50, okay? And so that means that the rise is 50. And then the run, same thing. I'm going to go from the spot of the left point to the spot of the right point, okay? So starting at the spot of the left point here, let me draw that in a different spot here, to the spot of the right point here. Okay, so I'm just going to count over. So I'm going to see 1, 2, 3, 4, 5, right? So I moved over 5 squares. And if I take a look at the scale down here, we can see that each box just represents 1. And so then what's happening is I moved over 5. Okay, and then I always want to reduce to lowest terms, right? So 50 divided by 5, I'm going to switch back to blue here, is equal to 10. Okay, so that's the slope of the blue line. Now, let's change into our red. We're going to calculate the slope of the red line. Same idea. Okay, so I know that m, or slope, is equal to rise over run. Okay, and I am going to do the exact same thing that I did in the first example, which is going to start off by finding any 2 points, okay? And to show you that you don't always have to start with the first point, I'm just going to start with like a random one kind of in the middle of the graph, okay? And then I'm going to count over to here, okay? And so same thing. I'm going to count from the spot of the left point to the spot of the right point for rise. Then I'm going to count from the spot of the left point to the spot of the right point for run. Okay, so start here at the left point, okay, and I'm going to count to the level of the right point. Okay, so I can see that I went up again 2 squares, right? And again, I can see that I went from 75 to 125, so that's up 50. So I rose again 50. Okay, and then this time the run is going from the left point to the right point, so I'm just going to move across until I find that next point, right? So you can see that I went across 2, right, two spots, and it means I went from 3 to 5, so I increased by 2, so the run was 2. And again, when I reduce into those lowest terms, I'm going to see that that becomes 25. Okay, next example. Oops, sorry ladies. All right, so we're going to determine which line below matches with each provided slope. Okay, and so the way that I'm going to do this is I'm actually just going to calculate each slope, and then we are going to just cross them off as they come, okay, from the list over here that I gave you. All right, so let's start here by calculating the slope of each of them. Okay, so first thing you might notice on this example is that I gave you 2 points on each of the graphs, right? So you can see that I actually already labeled the points for you. In the earlier example, we just picked 2 points, and that is okay. Okay, but sometimes they might already be kind of highlighted for you, and if that is the case, then it probably is easier to use those points. Not necessarily, you don't have to, but I would maybe just recommend it because they're already given to you. Okay, and so what we're going to do is we're going to count the rise and the run in each case. Okay, so let's see if I can just zoom in a little bit here to give me some writing space. Okay, perfect. Okay, so from this bottom point, we're going to count to the top point. So I'm going up 3. You can see that, right? So that means the slope is going to be 3 over something. And you can see that as I run, I am going 2 to the right. So that is equal to 3 over 2. Now, because 3 over 2 is already in lowest terms, then this is done. Okay, then we can take a look at our list over here, and we can cross out the one that we just used, right? So 3 over 2 is finished. So we've matched that to the graph. Okay. Whoops. All right, so let's do this one next. Okay. So we're going to start from that left point, move to that right point, just like I've been saying. So I'm going to count the vertical change, right, the rise. Okay, now you're going to notice that in this case, the left point is actually higher than the right point, right? So that's a new circumstance that we haven't come across yet. And I want to just let you guys know that there is still significance to that, okay? So you're right to notice that we're actually going down this time instead of up. And we went down 2. So the rise still has something to do with 2, but because we went down 2 instead of up 2, we're going to represent it by a negative 2. Okay, so when you move up, it's a positive number, and when we move down, it's a negative number. And then from there, we can just do the same thing as previously, which is count the run, right? So I'm going to move from left to right to go to that second point, and you can see that I again moved over 2 squares, okay? And so then when I reduce that, negative 2 divided by positive 2, that gives me negative 1. And you can see here that I have a negative 1 as an option, so we've already canceled that out as well. Okay, let us go to the bottom left example. Let's choose a different color, just for fun times. No. Why not purple? Okay, so again, we're going to start from the left point. We're going to move our way to the right point in both cases. So we're going to start with that rise. Okay, so we're going to move from the left point's level up to the right point's level. And so you can see in this case that I went up 3. Okay. And then the run, moving again from the left point to the right point, I'm going to move across 1, 2, 3, 4, 5, 6. Okay, so that gives me 6. And then because we always reduce to lowest terms, 3 over 6 is going to reduce to 1 over 2. Okay, and we can see that we do have a 1 over 2 slope over here, so that's perfect. We can cross that out. And if we've done all of our work right, we're going to end up with a negative 3 over 2 slope on this last graph. So let's see if our theory is correct. All right, so slope equal to rise over run. Let's start with the rise. So I'm going to go from the left point to the right point. You should be seeing the pattern by now, I think, hey? So we're going to go, and in this case, you're going to see again that we're counting down as we go to the second point's level. And so that means, again, remember that there's going to be a negative number in the top of our fraction. And in this case, that negative number is negative 6, right? Because I went down 6 squares to get to that level. Okay, there we go. And then I'm going to go across to find the run. So in this case, I went from left to right 4 spaces. So that's going to be a 4. And I'm going to reduce, as always, to lowest terms. Okay, so there is my slope of negative 3 over 2. And if we take a look back here at the list, voila! That is exactly the number we were looking for, so I can also cross that off. All right, so there we go. That's that example. Okay. So you can see in each case, all we did was start at the first point, the leftmost point, and move over to the rightmost point, counting up or down, and then from left to right. A quick note, if you were to count from right to left, if we were going to move to the left, then you would be counting a negative run, okay? So when you move from left to right, just like how we read, then that's a positive run. So that's why all of our denominators have been positive so far, like here, and here, here. But if you were, for some reason, counting from right to left, then that would be a negative run. However, I always recommend that you always count from left to right, so it's always positive, okay? So that's just a quick note there. All right, let's go to the next page. Okay, now that we've looked at actually calculating some slopes and looking at graphs of them, let's talk about what they actually mean, because I'm guessing some of you will have noticed a few patterns. Okay, it's okay if you haven't though, that's why I'm here. I'm going to tell you about it. All right, so the first thing you might have noticed is what we call the magnitude. And the magnitude is really just a fancy word for how close to 0 the number is. Okay, and the other thing you might have noticed is that some of our slopes have been negative, and some of our slopes have been positive. So what you're noticing is that the sign, oh boy, there we go, the sign of the slope is changing. So in one example might be negative and one example might be positive. So we're going to talk about what do those things mean. Okay, so the first thing is to notice that the magnitude does mean something. Okay, so the magnitude tells us how steep or shallow the line will be. So a slope value that is further, let me try that again. There we go, further from 0, okay, represents a steeper line, and a slope value that is closer to 0 represents a shallower line, okay, and another word for shallower, in case you're not sure, is flatter, okay. So let's do a quick example here to just talk about what does that look like on a graph, okay? So I'm just going to draw a couple sets of axes here, and I would recommend that you do the same, okay? These are just rough sketches. We're not doing any measuring, but just kind of the idea, okay, is that we have a coordinate plane. Oh, goodness. There we go. And then we have another coordinate plane here, and we're going to represent our slopes on that coordinate plane. Okay, so if I have a slope of 4 compared to a slope of 12, then I can see that 4 is much lower or much closer to 0. Okay, here's keywords, closer to 0 than 12. And so if it's closer to 0, then it represents a shallower or flatter line than a line that has a slope of 12. So a line with a slope of 4 might look something like this. Oh, I'm going to try and make that a little bit straighter. There we go. Okay, so we might have something that looks like that. Now, when compared to a slope of 12, which is a number that's further from 0, then we know that that's a steeper line. Okay, so we're going to represent that with a much steeper line. Remember that a line that's steep is less flat, right? So it's more vertical. So a line with a slope of 12 might look something like that. So you can see that when I look at this slope of 4, it's much shallower, much flatter, right, than this slope of 12, which is much less flat, much more vertical. Okay, so that's what the magnitude means. And so again, remember, magnitude is just how close to 0 the number is. And so since 4 is closer to 0, it's a flatter line, and since 12 is further from 0, it's a steeper line. Okay, the next thing is the sign of the number. Okay, and so this is kind of corresponding with what I was talking about in the last page about counting from left to right. So, like I was saying, that it's just like always smarter to count from left to right because that's how we read in English. And so, when we look at our slopes, I'm always going to do that. Okay, I'm always going to count from left to right. And keeping that in mind, a positive slope value means that the line is going up and to the right. Okay, so it means it's increasing as we go to the right. And that's because, of course, as our slope value represents rise over run, then the rise is positive, means we're going up as we go to the right. Okay, and a negative slope, that's our rise again, would be going down as we go to the right. So then that means that the line is going down and to the right. Wow, that's super messy. I'm going to rewrite that. There we go. Okay, so again, let's just draw a couple coordinate planes here to do our examples. Okay, so again, just rough sketches. They don't have to be any works of art, okay? Just to give you an idea of the coordinate plane. So, first example here is -4, and then we are contrasting that with +4. So, the reason that I just picked a positive and negative of the same number is because I don't want us to have to worry about the magnitude, okay? So, I'm not talking about the steepness in this example. I'm just talking about whether it goes up and to the right or down and to the right. So, -4 is going to be, that means that the slope is doing rise over run of -4 over 1. So it means that we're going down as we go to the right. Okay, so that's kind of what that means. You can put that all in brackets if you want to keep it. Okay. Oh boy. I can't write anything else. There we go. Okay, so it means down and to the right. So then that means that our line is going to be doing this type of motion, right? So as we go across the graph to the right, going this way, then we see that the line is going down. And alternatively, or I guess in the opposite case, if we had a positive 4 slope, then remember that that means positive 4 over 1. And so that means we're going up. The rise is going up as we run to the right. Oh, goodness. Okay, so that means this time if we had a slope of 4, again, not talking about the shallowness or the steepness, we're just saying that we're going up and to the right. So as I trace the line from left to right, it's going up. Okay, so there we go. That's what that means. Let's just do a quick example here. It looks like I've accidentally written a double negative into your notes, which I didn't realize. So this little negative sign here, you can erase that or just cross it out, okay? That's my bad. So just, scratch that little guy out. Okay, so we are going to list the 5 slopes that I showed you here from shallowest to steepest, and then we're going to do a quick sketch of each of them, okay? So remember that the steepest line will be the furthest from 0, and the shallowest line will be the closest to 0, okay? And it does not matter what the sign is for steepness or shallowness, okay? So when we're looking at steepness and shallowness, we're just ignoring the sign. We're just looking at how big or how close to 0 the number is, or how far from 0. Okay, so the first thing I would do is I'm going to rewrite all of these as decimals or whole numbers. Okay, so I know I have some fractions here, and I want to just get rid of all the fractions so that we can compare these appropriately. Okay, so remember that 0.25 is equal to a quarter. Okay, and that negative 7 over 2 is negative 3.5, so negative 3.5. Okay. Once I have these all in the same kind of form, they're just easier to look at that way. I'm going to look at what's the steepest and what's the shallowest and put them in order. So again, I'm looking for the number that's the furthest from 0. So if I was to put these all on a number line, I want to know which one is the furthest from 0 and which one is the closest. And I can see that 7 is going to be that number that's the furthest from 0. Okay, so I'm going to start with 7. Okay, then I'm going to just cross it off in my list so I don't accidentally do it twice. Okay, then I'm going to look for the next biggest number, ignoring the sign. Okay, so the next steepest line will be the next biggest number. It doesn't matter what sign it is. And so we can see that 3.5 is going to be the next biggest number because that's the next number that's far from 0. So I'm going to put that in my next line. Then I have 2.2. Okay, that's my next number. I'm just going now in order, trying to find the next biggest numbers. And then I can see negative 1 is bigger than 0.25, and then that makes 0.25 last. Okay, so let's do a quick sketch of each of these. Okay, so again, I'm just going to draw 5 coordinate planes. Okay, just quick sketches. They don't have to be anything fancy, just to show the 5 slopes. Okay, so here we're going to have the steepest, and then moving down the line. And I'm just realizing that I should have written negative 3.5 in the original form that it was given in, right, which was negative 7 over 2. Okay, so I'm just going to change that back. All right, now let's just do some sketches. And again, they don't have to be works of art, just approximations. Okay, so 7 is pretty steep compared to 0.25, so it's going to be pretty steep. Okay, so I'm going to see a pretty steep line occurring, and it's going up and to the right because it's positive. Next is negative 7 over 2, or negative 3.5, so it's not going to be nearly as steep. And the other key thing to notice is that it is negative, so it's actually going to be going down and to the right. Okay, so don't forget to change that, there we go, direction of the line. Next is 2.2, and 2.2 is pretty close to 3.5, but it is a positive number here, so it's going to be going up and to the right, and so we're going to have a similar line, but just going up and to the right instead of down. A little bit shallower, going up. Okay, then -1 is even shallower, right? It's even closer to 0, and since it's negative, it's going to be a decreasing line, so I'm going to have it going down and to the right. Okay. And then last but not least, 0.25 is positive, so it's going to be going up and to the right, but it's very shallow, right? 0.25 is very close to 0, so you're going to see that this line is like barely more than flat, right? It is more than flat, it's still going up and to the right, but not by much. Okay.